All right, so I'm trying to work on different trig identities problems. And you have these things in the formula packet, so you don't need to memorize everything. You just need to recognize that your main tools are that for any angle, sine squared plus cosine squared is equal to 1. And remember, that's just going a squared plus b squared equals c squared on the unit circle. You also know that tan is sine over cosine. And you have your double angle formulas and your angle addition formulas. Okay, so let's look at a couple example problems. So, for example, if I'm looking at trying to prove something like this, 1 minus cosine of 2 theta over 1 plus cosine of 2 theta, and I want to prove that that equals tan squared theta. Oops, I forgot to write my double angle identities. So here's a double angle identity for cosine. Cosine of 2 theta is cosine squared theta minus sine squared theta, and sine of 2 theta is 2 sine theta cosine theta. All right, so what I see here is I've got an example, and I'm just going to work with the left-hand side, and I'm just going to use my double angle formula 2 times. So the left-hand side becomes 1 minus the double angle formula for cosine. Cosine squared theta minus sine squared theta. And the bottom becomes 1 plus the double angle formula. I guess that the parentheses are not really necessary on the bottom, but I wrote them anyway. So then we have on the top, distribute the negative, 1 minus cosine squared theta plus sine squared theta. And on the bottom, we have 1 minus, I'm just going to rearrange the order, 1 minus sine squared theta plus cosine squared theta. Now, I always write this identity in the top left corner, sine squared plus cosine squared. I always write it like that, but you also have to recognize that you can subtract and change it around. So if you look at, for example, 1 minus cosine squared, how could I make it 1 minus cosine squared? Well, I could take away cosine squared from both sides. All right, sorry about that. So the 1 minus cosine squared is just going to be the same as sine squared. So I can replace this part with sine squared theta. And similarly, if I do 1 minus sine squared, I can replace this part with cosine squared theta. So if you look at what we got now, after that, I've got 2 sine squareds on top, and I've got 2 cosine squareds on bottom. So 2 over 2 is 1, and I recognize that sine over cosine is tangent, so this is equal to tangent of theta squared. All right, let's look at another example. I'm going to just be using those same couple tools. Let's say I'm trying to show that cosine squared of 1/2 x equals 1/2 1 plus cosine x. Yeah. All right. Another interruption. That's okay. So if I'm looking at this problem here, I have to figure out what tool can I use that I could use 1/2 x in it. Well, I know that double angle formula again. I know that if I did cosine of 2 theta, I can make that cosine squared minus sine squared. In other words, if I did cosine of 2 times 1/2 x, I can make that cosine squared 1/2 x minus sine squared of 1/2 x. So let's try that out. That means that cosine of x is equal to cosine squared a half x minus sine squared a half x. Okay, so let's try that. So I have here cosine squared of 1/2 x, and I have that right here in my formula. And I also have this sine squared, but that's kind of a problem because there's no sine in the thing that I'm trying to prove over there. But I know that for any angle, I can go cosine squared theta plus sine squared theta is equal to 1. And just like I did a few minutes ago, I know that sine squared is 1 minus cosine squared. So I'm going to take this version of my cosine formula, and I'm going to replace sine with 1 minus cosine. So this is another version of the formula that you can see in your formula packet. You'll see that you can write it as, I'm going to do one step of simplification first. I've got cosine squared of a half x minus replace sine squared with 1 minus cosine squared of a half x. And think about what we're doing here. We're subtracting 1 and we're subtracting a negative cosine. So that means we actually have 2 copies of positive cosine minus 1. And you might recognize that as an alternate version of the double angle formula for cosine. So what that means is this right here is equal to just regular cosine x. So let's compare where we're at now to the problem we're asked to prove. The problem we're asked to prove has cosine squared by itself. So we've got to take this, pop it up here, and we've got to make cosine squared by itself. So I can do that by adding 1 to both sides. So cosine x plus 1 has to equal 2 cosine squared of a half x. Then I can divide both sides by 2. And that's the same as multiplying it by a half. And then I've got the statement that I was asked to prove. Boom. Then the question actually had a part B on it, and we'll just use our answer here. The question had a part B, which was like prove that sine squared of 1/2 x is equal to 1/2 1 minus cosine x. Well, I'm just going to use this example or this result that I just got already, because I know that sine squared is the same as 1 minus cosine squared. So now I know that sine squared of 1/2 x has got to be 1 minus the answer I just got, cosine squared of 1/2 x. And I can just replace the answer I just got. And then all I need to do is distribute this 1/2 and just sort of collect like terms. So I've got 1 minus a half cosine x minus a half. 1 minus a half is equal to 1/2. So I just have 1/2 minus 1/2 cosine x, which is the same as what I was asked to prove. So that was just a couple trig identity problems. Please let me know if you got any other questions.